In this video, we're going to be talking about combined gas law. In combined gas law, there's an equation for it, so we're going to look at it right now. Initial pressure times initial volume divided by initial moles times initial temperature equals to the final version of it. And we use that to solve for combined gas law problems. For example, if the initial temperature of a gas is 3.7 atm, which is pressure, when the 8.3 mole of gas occupies 5.5 liters, when the temperature is at 298 Kelvin, what is the final pressure if the temperature is increased to 450? So now we know what our givens are. So our givens are P1, which is 3.7, the pressure, the initial pressure, N1, which is the initial moles, V1, which is the initial volume, 5.5, and then the rest. So the unknown we need to solve for is P2, which is the second pressure, or the final pressure. And we can see that in the question, what is the final pressure if the temperature is 450 K? And we know that 450 K is very important because this is the final temperature, so we need that definitely. And the equation for it is as shown above, which is pretty the same. And since we have to solve for P2, we have to isolate it. So in order to isolate it, we just move it around, and then we should get this equation because P1 and T2 are divided, so we have to multiply it, blah, blah, blah. You get the deal. So now we're going to solve for it, which is pretty simple. We just put in the numbers, which is substitution. So put 3.7 times 450 divided by 298, sorry. And then when we solve it, we can find our temperature, which is this ugly number. And then we always round it to the nearest hundredths, which is 5.59 atm, which is in pressure. And that's what we want because it's the final pressure. So any variable that's not mentioned or appears only once is extra information. So basically all it's saying is that you can notice that some of the variables aren't actually shown here. And that's because those variables are only shown once in the example. So keep that in mind. And in the standard temperature pressure, if the temperature is 1 mole, it's always going to be 273 Kelvin. That's always. So for some more examples, we're going to go through V2 for combined gas law. So let's see here. So we're given volume 1, which is 47, times T1, which is 270, temperature 2, which is 298, and we're trying to find the volume, the second volume. So in order to do that, we're going to have to find an equation for V2. So if you look here, V2 is right here, and in order to solve for it, we have to multiply N2 and T2 on the other side. So we would get P1 times V1 times N2 and T2. And then since we have P2 up here, since it's multiplying, we have to divide it. So we can isolate the final volume, which is what we want to find. So and then P2 multiplied down here because it is dividing. And then we plug it in the calculator. It's pretty simple. Before we do that though, we have to look at our variables. So you can notice that some of the variables in the equation isn't actually there. So what we do is we just get rid of them, because any variable not mentioned will be just information we don't need. So we know we have V1, T1, T2. So we don't have moles and temperatures. So we can just simply cross it out. Well, we do have temperature, sorry. We don't have pressure. We don't have pressure and moles, that's what we don't have. So the equation we have here is actually final volume equals initial volume times final mole divided by initial temperature. And if we put that in the calculator and plug it in, we would get 51.87. In this example, we have the first pressure, the first temperature, and the final temperature and the final pressure. In order to find what the second temperature is, we have to look at the equation for what we don't need, which is volume and moles, which is not there. So we just cross them out. So crossing them out will equate to P1 over T1 equals to P2 over T2. And then we're trying to find what T2 is, so in order to do that, we have to isolate it. So first, you would multiply T2 to get it out of the denominator, so it's P1 times T2 over T1. And then this should be simple from now. It's pretty easy, so you get P2 times T1 divided by P1 equals to T2, and if you put that with the values that are given, you would get P2, which is 16, times the temperature, which is the first temperature, which is 123, divided by 3.2, I believe. And then boop boop boop, calculator, you would get 615 Kelvin. So that's how you find temperature. It should be the same thing for moles, because it's at the denominator. It depends on your problem.